There are more than 300 ways of proving Pythagoras' theorem, and in this video I'm going to show you my favorite 3 ways of proving it. Let me remind you that in a right-angled triangle, the square of the hypotenuse equals the sum of the squares of its legs. And the first way to prove it is an old classic area proof. We're going to use the area of a square. So first off, I'm going to construct a square with a side that is equal to the sum of the legs of the triangle. So its side is a plus b. Therefore, its area is a plus b squared. Now I'm going to divide each side of this square into segments of lengths a and b, like so. Now if we connect these points, we've got ourselves a quadrilateral, which suspiciously looks like another square. Let us prove it. Since this angle is right, this triangle is congruent to our original triangle because of the side-angle-side postulate. Now this segment equals the hypotenuse of the original triangle, which means that it equals c. Similarly, that triangle equals the original triangle, so we've got c here, and this segment is also c, and we've got c here too. But this only means that this quadrilateral is a rhombus. So we need to prove that at least one of its angles is right. We're going to use the fact that these two angles add up to 90 degrees, so do these two angles, because they're similar to them, which means that this angle is right and the rhombus is in fact a square. So the other way to express the area of a square is to say that it equals the sum of the areas of a square with the side c, this square, and 4 right-angled triangles with legs a and b. Or in other words, it's c squared plus 4 times 1/2 of product of a and b. So we have a squared plus 2ab plus b squared equals c squared plus 2ab. And if we cancel these two terms, we have a squared plus b squared equals c squared, which proves Pythagoras' theorem. The second way to prove Pythagoras is to use mean proportionals. Let me remind you what a mean proportional is. Let's consider a right-angled triangle ABC, and let's drop the altitude to the hypotenuse. We'll call the base of the altitude d. Now look at angle A. It's an angle of 2 triangles, ADC and ABC. So if we look at it in triangle ADC, then cosine A equals its adjacent leg divided by hypotenuse. So it's AD divided by AC. On the other hand, in triangle ABC, cosine A equals AC divided by AB, because in this triangle AC is adjacent leg and AB is the hypotenuse. Now since this is a cosine of a same angle, we can establish a proportion. AD divided by AC equals AC divided by AB. And from this proportion we can establish that AC squared equals the product of AB and AD. Now using similar reasoning for cosine of angle B, we can state that BC squared equals AB times BD. Now if we add these equalities together, then we have AC squared plus BC squared equals AB times the sum of AD and BD. But AD and BD sum up to AB. So we have the square of the hypotenuse on the right-hand side of this equation, which again proves Pythagoras' theorem. And the final third way to prove Pythagoras' theorem is using Ptolemy's theorem. Now Ptolemy states that for a cyclic quadrilateral or a quadrilateral inscribed in a circle, the product of the diagonals equals the sum of the products of opposite sides. Or in other words, if we call this quadrilateral ABCD, the product of AC and BD equals the sum of AD times BC plus DC times AB. So product of AD and BC plus product of AB and CD. Now how does this help us prove Pythagoras' theorem? We will use the fact that every rectangle is cyclic and there is a lot of equal segments in a rectangle. So let's say that the length of its diagonals is C and the sides are A and B. So by Ptolemy's, C times C equals B times B plus A times A, or C squared equals A squared plus B squared, which again proves Pythagoras' theorem. Thank you for watching. I hope you learned something new.